Hola, mi clase! We are doing 8.3 quadratic functions in standard form. So we've been doing quadratic functions in vertex form. Now we're going to do it in standard form. So the standard form of quadratic function is f of x equals ax squared plus bx plus c. So notice we have seen this before when we were factoring and things like that. So that's where that quadratic comes from. Sorry, I'm kicking my desk. So we are going to graph quadratics using this form instead of vertex form. So it says, what information does C provide about the graph of f of x equals ax squared plus bx plus c? So we have three examples. All of the c's have been highlighted in red. So the first function says f of x equals negative 2x squared plus 4x minus 3. And if we look, the 3, that's a really horrible circle, is negative. So C equals negative 3. And what that's going to give us is our y-intercept of 0, 3. And if we look on the graph, there it is at 0, 3. So the C gives us a y-intercept where it will be 0, comma, C. And that's going to be true for all of these. Notice these are all negative 2. That's why they're all flipped upside down. If you notice, they're all upside down, negative 2, negative 2. So still this negative on the front of A is going to tell us if it's up or down. But if you see that, see negative 1, C is negative 1, it's at 0, negative 1. We can graph that as a point. And we have positive 1. So like I said, it always will be 0, C, but you always got to make sure you take the sign in front of it. And then you can see they graphed 0, 1. So the C gives us the y-intercept of 0 and whatever C is. Okay. Now, we're going to go into, now how else do I graph it? I obviously can't graph it just with that point. I don't know where my axis of symmetry is at that point to find out this point. Okay, these graphs have already been done that way, right? Here's our axis of symmetry. So we could then find this point, but we still need the vertex to be able to graph. So that's the next example, is it says graph f of x of 2x plus 4x plus 3. What are the axis of symmetry? So what is the axis of symmetry? The vertex and the y-intercept of the function. So it is a positive A, so we know it's going to be upright. Here is my y-intercept. So our y-intercept will be 0 and 3. That is actually something I can graph right now. Here it is, 0, 3. So I'm going to do that. Now, to find the axis of symmetry and the x-coordinate of my vertex, this is what we're going to use. Okay, so the x will equal negative b over 2a. And when they say negative b over 2a, they mean this a and this b. So it would look like this. We'll go equals negative. Well, b is 4, so we're going to go 4 over. A is 2, so we're going to go 2 times 2. So it would get us negative 4 over 4, which will then get us negative 1. So the axis of symmetry is then x equals negative 1. And so we can also put that in. So we're going to draw a dashed line right here at x equals negative 1. And then this is my x of my vertex. So since my vertex is going to be a point, it would be negative 1 comma something. And what we're going to do to find the y is we're going to plug it into the function. So we'll go f of negative 1, because that's what we're trying to find. Where is it at negative 1? We'll go 2 times negative 1 squared plus 4 times negative 1 plus 3. So we'll get 2 times 1, because negative 1 squared is just 1, plus negative 4 plus 3, and we'll get 2 plus negative 4 plus 3. So if we do all this math, 2 plus negative 4 is negative 2, plus 3 would get me positive 1, and that is my function at negative 1. So that means my vertex is at -1, 1. And so we would put it right here. Now, we have 2 points, and the really nice thing is we have at least one of the points that's 1 away from my axis of symmetry. And so remember, if it's an axis of symmetry, if it's 1 away here, it's just 1 away on the other side. Okay, now I want you to notice the a is 2. That's the same a. And remember, for my parent function, my first point was always 1, 1 away. If you notice, it's now 1, 2 away, because it times that space by 2. My second point's 2 away, and then 4 away, 1, 2, 3, 4, but it would become 2 away and then 8 away, which won't fit on my graph anyways. But it would be, right, 2 away, and then it'd be 1, 2, 3, 4, 5, 6, 7, 8 way up here. I think that's at like 9, because 2 times that would get me that. But since it's not going to fit on my graph, I'm going to just do my best to draw a U. That was not a very good U. There we go. It's a little bit better. Oh, that's a horrible arrow. And there would be our graph. So I was able to graph that off my y-intercept and my vertex, and using the rules of axis of symmetry. It's 1 away here, it's got to be 1 away there. Okay, and so that's how I was able to graph that. It is upright because this positive a. All right, so let's graph this now. So again, this is my y-intercept. And so we would get 0, +4, because it's a +4. My a is just +1, so I know it's going to be upright. And then I need to find my x and my axis of symmetry, so I'm going to go -b/2a. Sometimes you write it as -b/2a like this. It's really up to you. So we would do -2/2 times 1. A is 1. And so we get -2/2, and we again get -1. So that means my axis of symmetry is right here at -1. And to find, that's also going to be my x-coordinate and my vertex, right? -1 something to get our vertex. And x equals -1 is my axis of symmetry. Okay, so we're going to go function at -1 equals 1 times -1 squared plus 2 times -1 plus 4. -1 squared is 1 times 1 is just 1, plus 2 times -1 is -2 plus 4. So we get -1 plus 4 is 3. So, oops, function at -1 is 3. So I put my vertex is at -1, 3. So -1, 3 right here. Now you can see my first point is just that 1 way. It's a parent function, matches it. And this is 1 away, so I put the other one right here, 1 away. I technically can graph it right from here. I only need these points, but if you'd like, we know that the next point should be 1, 2, and 1, 2, 3, 4 away to match that parent function. And so 1, 2, 1, 2. So you can add those points as well. It is best to try to put as many points as possible to try to get that U as best made. And so that's what it would look like. Again, I just used the parent function. My first point's 1 and 1 away. My second point's 2 and 4 away. And that's how I was able to get that. All right, I'm actually going to have you guys do this one and try it out. Just remember, this is your y-intercept. Okay, axis of symmetry, and my vertex will be -b/2a. It is a negative, so just a hint, it will be upside down. That'll be my hint for you somewhere. Okay, it'll be upside down somewhere. So that one I'm going to have you guys do kind of as an independent practice. All right, it says the trajectory of the water from fountain A is represented in this function. So it's this fountain right here. You can see it is upside down parabola. Notice it's a negative, so upside down parabola. and it's in standard form, while the trajectory of water from fountain B, that's this one right here, is represented by the table. Compare the vertex of each function, which trajectory reaches a greater height in feet. Okay, so I'm going to just kind of color these in so you can see them a little bit better. That's not a very good coloring, but there you go. And then fountain B is, oh, that's a horrible color. You can't even see that. Let me pick a brighter color. Maybe this will work. Oh yeah, that's a little bit better. There we go. Fountain A, oh, it's right there. So we know for fountain A, we have to use our negative b over 2a to find our vertex. So I'm just going to do that. So negative b over 2a would get me, I'd go negative 2 over 2 times negative 1. See, negative 1 will get me negative 2 over negative 2. So it is a double negative, and so we can think of it as 2 over negative 2 would get me negative 1, but we're really asking for the opposite of that, and so our x is going to be negative 1. I don't know why all of these are coming out as negative 1, but they are. Oh, sorry, positive 1. Duh, negative, negative, positive 1. Yay, not negative. Okay, positive 1. So once we have our x, we then need to go solve for our y. So I'm going to go function at 1 equals negative parentheses 1 squared plus 2 times 1 plus 8. Well, 1 squared is 1, and then I take the opposite of that. So negative 1 plus 2 plus 8. So this is 1 plus 8, which will get me 9. So my vertex will be at 1, 9. Okay, so there's our vertex for A. Now for B, it's in a table for us, so we need to remember that our y's on one side and the other always match. So if we just look, it goes 5, 8, 10, and then it goes back to 8. This right here is my vertex because that is the maximum height that it reaches. And since I know it's an upside down parabola, I'm looking for the maximum. And so this is the highest height it can be. It's my max. And so that's my vertex. So now in a table form, it's really nice to find, especially if they give you the vertex, it's really easy to find that vertex because there's the highest point it can be. And so it says which trajectory reaches a greater height. Highest height is fountain, actually I'll do it in the color fountain B. And I'll just write it right here. Fountain B. And you can even say 10 feet. There we go, we're done. All right, so main things to remember, C will be your y-intercept, and your x is negative b over 2a, and that will get you your axis of symmetry, and the x coordinate of the vertex. Okay, so those are the main things. And then, like I said, kind of your independent practice is doing this, and hint, hint, remember it's upside down. All right, until next time, adios.